generally disregard this thickness of the conductor or the line charge. The second is what the surface charge. If the charge is what distributed along a surface, okay, then how they are going to create its impact, their own impact in the surrounding. Then the volume charge, the group of charges. Okay, so generally we consider they are spherical in shape, just for the sake of simplicity. Otherwise, it can have any shape, okay, depending on the boundaries. So volume charge density is it's related with what your Xerox machine, you can say. Then the printer, inkjet printer is there, or it's there. So there we take this relation, or we consider this relation, volume charge density. Okay, so this is what we have discussed so far. Now we'll move to the problem, then flux density, and then numerical of the flux density, and that will be enough, I think, for today's session. I hope you remember the formulas, otherwise will be given to you in between. So this is one problem. Planes x equals to 2, y equals to -3, okay, respectively carry charges 10 nanocoulomb per meter square and 15 nanocoulomb per meter square. Okay, so there are two sheets which are located at x equals to 2 and y equals to -3. And they are carrying what? Surface charge density. So just have a look at what the unit of the surface charge density. It is coulomb per meter square, okay? But the amount of charge is very, very small. So it's in nanocoulomb per meter square. Now there is another charge distribution. If the line x equals to 0 and z equals to 2 carries charge 10 pi nanocoulomb per meter, calculate E at 1, 1, -1 due to the 3 charge distribution. Okay, so simply in the last lecture we discussed that the electric field intensity or the Coulomb's law, they are linear in nature. So you can, if you want to find out the force or the electric field intensity because of the multiple charges, so what you can do, individually you find out the electric field intensity and then just add up all. So you will get the resultant electric field intensity or the force. Okay, so one by one we'll see how to do this. Just do one thing. You just note down these two values, because I will be using tab now. So just whenever I ask now what is the value of surface charge, just let me know those charges. Okay, charge density, so that I can use this in the formula. So take a screenshot of this, or you can note it down. Okay, so first it is said that two planes are there, two sheets are there which are carrying this surface charge density. So wait.
Recording in progress.
Okay, screen is visible now. I'm sharing a blank PPT.
Yes, sir.
Okay, so people are coming in between. Okay, anyways, so we'll draw first this rectangular coordinate system. Okay, like this. Here, it's X, Y, Z. Okay, and the negative y-axis, negative x-axis, and the negative z-axis. Okay, so first sheet is at what? X equals to 2, right? So that sheet is present here. Okay. So this coordinate is what passing through it. This is actually the size of the sheet is not mentioned. Okay, so if the size of the sheet is not mentioned, so you have to take it as what? Infinite. That is what? Ideal surface charge distribution. Means the sheet is too big. It's very large sheet. Okay, and the another one is present at y-axis, somewhere at x equals to 3, I think. Okay, -3. So please check the this data which I'm sharing. That one sheet is at x equals to 2, and another sheet is at what? X equals to -3. Okay, so first what we'll try to do, that we will try to find out electric field because of the individual sheets. Okay, because the same formula will be used, and for the line charge we will talk separately because there the formula is going to differ. Now what is the this formula for electric field intensity because of a sheet? Anyone remembers? Electric charge distribution because of the electric field intensity because of surface charge distribution. So it is given by what? Surface charge density divided by 2 times of epsilon naught and plus minus an. Okay. So before we now what I will do, that I will take the field intensity because of this charge. Okay, so surface charge density, the sheet which is present at x equals to 2. Okay, so what you have to do, simply you have to put the values of rho s, then 2 epsilon, because everything is constant here. Rho s for this sheet is, anyone tell me what is the surface charge density because of sheet at x equals to 2?
Ten nano centimeter per meter square.
10
10
nano.
nano coulomb per meter square.
10 nano coulomb per meter square.
Yes.
Okay. And from this it is 15 nano coulomb, right? The other one.
Yes, sir.
Okay. Okay. So you can see that when you face such kind of problem now, then at that time what you have to do, simply, because it's formula based. All right. It's formula based. So simply you have to substitute the values. Okay. So here it is 10 nano. So 10 raised to minus 9 coulomb per meter square. Okay. This divided by 2 into epsilon naught. That's a constant, 8.85 into 10 raised to minus 12. Okay. Then plus minus an. So this calculation can be done by yourself very easily. Okay, this much. Simply put all this value in the calculator, you will get the result. The major part is what? Means the important is what? That is more important. Okay, so please tell me what is, where you are asked to find out this field intensity, at what location? 1, 1, -1, right?
Yes, sir.
Okay. So 1, 1 means what? See this, if I consider this first sheet, which is at x equals to 2, this is x-axis, right? So this sheet is present at x equals to 2 meter. So 1 will be, of course, inside it. So let us consider that x is 1 here. Okay, y it is here. So the intersection of this, okay, here. So it is what? 1, 1. But we have to consider the z-axis also. So z is what? Negative. It is -1. So it is somewhere here. Okay. So you have to just take this point 1 meter down somewhere here. Okay. So this is the location where you are asked to find out at this location. You are asked to find out field intensity. Okay. So why this location is important, so that you will come to know whether the field is what? Now, whether the field is what? Before this sheet or after this sheet, means we'll redraw that part here. This is the x-axis. Okay. So that sheet is present here, right? It's passing through like this. So that point is present here or here. Okay. Because the field radiated by this sheet will be what? Normal to this. So the orientation of the field will be like this. And on the other side, it will be like this. Okay. So this diagram is important. Huh? You see, most of the time we have to do the imagination work. Okay. The field is what? Either it is moving in the positive x direction or it is moving towards the negative x direction. Okay. These are the two possible directions for the electric field. And this AN is nothing but that direction of the field only. Okay. This AN. So either it will be plus or minus, that depends. So that totally depends on the location. So location is what? Somewhere here. Okay. So somewhere here means what? The field will be, field is going towards what? Minus x direction. And if suppose the field, the location, your desired location where you're interested to find out the field is what? Here. So the electric field here is what? It is moving in the positive x direction like this. Okay. So the location, it matters because the magnitude of the field is not going to change. It's a constant. Only the direction is going to change. Now, since the desired location is what? Somewhere here. So you have to just check what is the direction of the field. So it is what? Minus AX. So your AN is going to be minus AX. Okay. So what you have to do simply in this formula, simplify this value, whatever you get. Can you simplify for this too for me? 5 divided by 8.85 into 1000.
So 44.25 into 10 raised to 3.
था, मैं इरेज ही कर देता हूँ if you are knowing the answer. 44
44.25 into 10 raised to 3.
44.5.
25.
Okay, 25 into 10 raised to 3. Okay, now the direction is going to be minus ax cap, means it's the field orientation is towards negative axis. So this is the electric field intensity because of sheet surface charge density, okay, which is located at x-axis. Similarly, you have to try for what? The another sheet. So I will draw it here. This is y-axis. This is the origin, okay. So another sheet is what? It is present here, like this. This is what? Minus y-axis. So the field is always normal to the surface. So of course, one field will be moving, means the group of field will be moving towards positive y-axis, and the another group of field will be moving along negative y-axis. Okay. So here the orientation of the field will be either plus ay or minus ay, but you have to, for that you have to check what is the location where you're interested to find out the field intensity. Okay, so location is here. Okay, so here you can see that the field is what? It is in the positive y direction. So field density, sorry, field intensity because of the surface charge density located at y-axis. It is now this time it is what? It is going to be 15 nanocoulomb per cubic meter. Sorry, per centimeter square. Per meter square, not centimeter. Now, if it is centimeter, then you have to multiply it by 100. Okay, so just take care.
44 कैसे आएगा?
नहीं, मैंने नहीं निकाला है. So whatever he said that I have.
564.97 आया मेरे को.
Yes, sir.
Because
Yes,
it was 5 divided by 8.5, ना? हाँ.
और
It should be less than 0.5. 5.
564
6 के आसपास आएगा.
564 इतना है.
Yes
कितना
sir.
आ रहा है? Just tell me.
564.97.
Okay. Fine. So please make correction. It is just for your understanding. मतलब जब भी मैं PPT share करूँगा उस time you will get the answer. But here just try to understand what is the procedure, because कुछ numericals रहने वाले हैं exam में, and you practice this numerical only है exam के लिए भी.
Okay, sir.
हाँ. Here it's 15 nanocoulomb as far as I remember. 15 10 raised to minus 9 divided by 2 into 8.85 into 10 raised to minus 12. And the direction is going to be positive AY. So the total electric field intensity because of these two surface charge density will be minus. Now you can tell me the actual figure for the first part of the problem. कितना है वो?
564.97.
56. Point 6.
564.97.
0.56.
564.97. First वाले का सर.
97. इतना ही है?
Yes sir.
Okay. And second वाला it will be AY. इसका किसी ने निकाला है तो can tell me.
847.45.
87. आगे
847.45.
47.45 AY. So this is the total field because of the two sheets. Line charge भी बाकी है अपना. Line charge we have not included. So if you are aware with the vector part, vector concept, then you can find out what is the magnitude of the electric field intensity at 1, 1, -1, and what is the direction of the field. Okay, because both the axes are involved. Okay, so force जो है वो inclined हो जाएगा. Reason क्या है उसका? Because the two charge distributions ना they are they are not same. एक के पास 15 nanocoulomb per meter square and another is having 10 nanocoulomb per meter square. Distance is not a matter because you can see the formula में there is distance is not involved anywhere. So sheet कहीं पे भी रहने दो उस axis पे. Point of observation is not changing. Then your answer will be always same. This much only. It's not going to change.
सर उसकी डायरेक्शन मतलब माइनस या प्लस वो इसमें कैसे लेने का वो एक बार वापस बताओ ना कैसे
Okay.
करना.
Okay. So for that, like suppose if you look at this only, this one. Okay, I will draw a fresh sheet here. Suppose this is z-axis. Let us consider this is z-axis. Okay. And your sheet is what? It is present like this. Okay. And it contains what? Charges. Like this. So already we have, see, to solve the problem, your theoretical idea should be very much clear. वो जितना ज़्यादा clear रहेगा problem solve करते टाइम उतना कम difficulty face करना पड़ेगा. So the theory of surface charge density says that whatever electric field will emerge or whichever will come out from the surface of a charged sheet, then electric field will be always normal. Normal is perpendicular to that sheet. So perpendicular to the sheet means what? एक तो ऐसा हो जाएगा, ठीक है? Which is going upside. So you can see that it is what? Along positive z axis, and the another will be what? Going downside. So it will be what? Along minus z. So any field which is what? Heading upside, it is your az cap, and any field which is what? Heading downside, it is minus az cap. So if suppose you are interested to find out the field intensity somewhere here, so the direction, you can see that the field is what? Going downside in this, at this point, or any point which is below the sheet. So the below the sheet means what? The electric field is what? It is going in the negative direction. So if your point of interest or wherever you are asked to find out the field intensity, that is what? Below the sheet, then the direction of the field will be what? Minus az axis. And if you are suppose point of interest is what? Above the sheet, then the direction will be plus az axis. Similarly, it is done here. So this is what? It is the part, it is the example of this sheet, okay? So sheet is what? Along z axis. So along z axis, so once again you apply the same rule. Field, it will be normal to the sheet. So one group of field will be what? It will be going like this. Another group of the field will be what? Going like this. Okay. So all these fields, they are divided in two parts. One moving in the, and now this is my, sorry, it's positive x-axis. Huh? So there is a group of field which is what? Going in the positive x direction, and another group is what? Going in the negative x direction. So if your point is what? It is before the sheet, means somewhere here. So here the direction of the field is what? It is following negative axis. That's why minus ax liya tha hum logon ne. If your point of interest is somewhere here, so you can see, just look at the sheet and check the direction of the field emerging from there. So it is what? Going like this. So you check the axis. So it is what? Parallel to the positive x-axis. So the field here will be what? Positive x. That's it.
Okay, sir, got it.
Fine. और किसी को कुछ डाउट है तो पूछ सकता है. Okay. So next we'll move to the line charge density. Okay. Line charge के लिए once again I will draw a fresh diagram. बोलने के लिए fresh है, अच्छे से बन नहीं रहा हो तो मुझे भी पता चल रहा है. लेकिन अभी तक because I am using this tab only for this lecture. तो उतना प्रैक्टिस हो नहीं पाता है. And rest of the time we are I'm using PPT. I don't require this kind of writing. Oh, here it's wrong. Huh? ये गड़बड़ हो गया. ये है z-axis. Okay, so the coordinate of the axis, this line, location of the line is mentioned. So what is the location? X equals to 0 and z equals to 2. Is it so?
Yes, sir.
Okay, so x equals to 0 means what? This is x-axis. So 0, it will be here, and z is what? It's here. Okay, so this coordinate is what? 0 comma z is 2 or 1.
2.
Okay, even though it is three-dimensional coordinate system, but I have mentioned only x and z here. Better I should include all. Confusion nahi hoga. So y and z is 2. Okay, so this is my x coordinate, then y coordinate, then z coordinate. So x, it is already mentioned that the line charge distribution means you are having a wire, very thin wire, that's why line charge, but it is passing through coordinates x equals to 0 and z equals to 2. Y is not mentioned. So if it is not mentioned, it means that it is running parallel to the y axis. Okay, so I will draw that line charge.
Sir, charge is on z-axis, right?
एक मिनट. हाँ बोलो अभी.
What I am asking is, charge is on z-axis or on parallel to y-axis?
Charge is, you just forget about this coordinate system.
Okay.
You are having a wire, okay, thin wire, straight, okay, and the charge is what? Present along that wire. Okay, now you are going to fit that wire in this coordinate system. Okay, so you will be given some instruction. Okay, इसको parallel z के parallel में रखो, या y के parallel में रखो, या x के parallel में, या randomly रखो. So here in this particular problem, it is said that it is at x equals to 0 and z equals to 2. Y is not mentioned. So if y is not mentioned, that it means that it is parallel to the y axis, because if it is running parallel to your y axis, then no need to define y axis, because your wire is present for all values of y. यहाँ पे भी wire present है, यहाँ पे भी wire present है, यहाँ पे भी present है, यहाँ पे भी present है. Length of the wire is not mentioned. It means that it is ideal situation. The length is very, very long, or you can consider that it is infinitely long. Okay, so इस infinite wire पे y का value अलग अलग जगह पे अलग अलग रहेगा. So no need to consider, because when you are saying ना coordinates अगर आप mention कर रहे हो ना, it means that it has to be fixed. उसका एक value मिलेगा, जैसा x का value मिल रहा है, z का value मिल रहा है, but y का value is not there. It means that it is running parallel to the y axis.
Okay.
Okay. Now you have to find out what the field intensity at this point, whose location is what? 1, 1, -1. Okay, now the formula for the field intensity, because of a line charge,
Recording stopped.
Okay, I'm once again back here. Hmm. Screen is visible.
Yes, sir.
Okay. So I was talking about the electric field intensity. So the formula for record
Recording in progress.
line charge is, there is line charge density, you should know, divided by, so there is 2 pi epsilon naught, okay, epsilon naught, and then here it's write r, okay, and then an, or instead of writing an, I can say that it's ar. Okay, so direction of the field is what? Along this radial direction. Okay, so see, you can apply the formula properly only if you are understanding each and every term. So like line charge density, it's okay, it will be mentioned to you. Okay, if you are asked to find out electric field intensity, epsilon naught is a constant, 2 pi is a constant, so there is not a problem, but you have to what? Work on this and work on this. So you have to understand what is the meaning of this and what is the meaning of this actually. Because your AR cap, it depends on the value of this R. So this R is what? Perpendicular distance. Okay, perpendicular distance joining your destination point, that is what? 1, 1, -1, and a line. Okay, so it is going to be 0, y, and 2. Okay, it's like this. So if we'll consider this particular problem, then the value of y here, it's unknown. So I can assume it to be what? 1. Why? Because it's a perpendicular distance joining the line, this line, and this point. Okay. So first understand this. This 2 is very important. This is what? The destination point where you're asked to find out the field intensity. And this is the coordinate of the line charge. So line charge is distributed along a line only, and the coordinate of the line is what? 0, y, 2. So y ka value should be 1. It should be this y, okay, this y and this y should be same. That's why I have taken as here y as what? 1. So if any query is there, you can ask why this y should be 1. If there is no doubt, then we can apply the formula.
Sir, how this y become 1?
So for that, you can have another figure here. Let us consider that this is z-axis, okay? And now let us consider that you are having what? 2 sticks. One is placed here, another is placed here, okay? So they are both are running parallel to the z-axis, okay? Now you are asked to what? Find out okay, I want to draw a perpendicular line and the z का value for this line should be what? Suppose 4. ठीक है, यहाँ से मुझे एक perpendicular line draw करना है which must connect to the other line. So what should be the value of z here?
4.
4, na? Why? Because this line is perpendicular, right? So same concept is here. If you are going to your here, okay, so you have to connect a line which will join this line
Can you
charge.
repeat that last statement? You were not audible.
This one, this part you are saying.
After that,
After that,
yes, sir, in between your
Huh.
was
so if you are going to connect these two lines with the help of a perpendicular line, okay, then this point and this point must be at the same height along these two lines at z equals to 4, and here also z equals to 4. But suppose you are saying that, okay, I will keep it here at z equals to 3, suppose. So the line, it will go like this. It becomes inclined. Now it's not going to be perpendicular, isn't it?
yes, sir.
So that's why when you're joining two lines, okay, and the line which is joining the two line, if it has to be perpendicular, then the one of the coordinates should be same for both the lines, okay? Like here, both the lines, these two sticks, they are parallel to the z-axis, okay? So if you want to draw a perpendicular line, then the value of z here and the value of z here is going to be same. It's 4 and 4. Similarly, in the line charge problem, this R is nothing but the line joining this point, okay, where you're interested to find out the field intensity and the line, but it's a perpendicular line, okay? So if I have to draw a perpendicular line like this, sorry, teda ho gaya. One second. Okay, I will consider this only perpendicular line. So, okay, it's like this 90-degree angle ho gaya. Perpendicular line if you are going to draw, okay? So whatever is the value of y here, same should be the value of here. Y ka value should be here. Both should have same value, then only this line will be what? Perpendicular. So whatever is the value of y here, same should be the value of y here also. That's why I have taken y equals to what? 1 here. Okay, so you have to just check your line is parallel to which axis? Y axis. Na? So when your line is line is parallel to any of the axis, na, then in the calculation, just do not bring that coordinate simply because, wait, let me admit, because like in our case, I will not bring y in calculation. Reason, simple reason is what? Because y for both the at both the locations, they are going to be same, 1 and 1. So if I take the difference of 1 and 1, it is going to be 0. Okay, so y will not exist only. So if the things are very much clear, it's fine. Otherwise, what you can do that you have to simply check if your line is running parallel to which axis. Do not bring that coordinate in the calculation. That's it. Remove it. Simple. Okay, now I'm going to find out R, and once again I will revise everything. Means this part I want to find out R. R is what? A distance, perpendicular distance joining the line charge and the destination point using a perpendicular line. Okay, so first what I will do, I will find out vector. Vector मुझे वैसे भी लगने ही वाला है. So vector joining these 2 points, this point and any point on the line, but the line joining this vector line which will join these 2 points must be perpendicular. Okay, so this is your destination where you're interested to find out the field intensity. Okay, and the field is coming from the line. Okay, so your line charge is going to act as a source. So source ka coordinate will be what? 0, y, 2, and destination ka 1, y, 1, 1, -1. Since I said that y of both the locations will be same, or your line charge is what? Parallel to the y axis. So forget about that y coordinate. You consider only x and z coordinate. So x is 1 and minus 1. Here it is 0 and 2. So finding vector is what? Destination coordinate minus the source coordinate. Destination coordinate means what? That coordinate where you're interested to find out the field intensity. So destination is this. So first coordinate is what? X. So it is 1. Destination का coordinate x का क्या है? 0. Okay. Since it is x coordinates, I will multiply with this x plus y coordinate. I said that line is running parallel to the y axis, so remove it, or you are knowing that at both the locations y is 1 1, so it is going to be 0 only, so I will not consider that part. Z it is now minus 1 and z, so the vector becomes ax cap minus 3 az cap. Okay, so this is the vector line joining the 2 points, this point, and this vector is what? Perpendicular to this line charge. Now my goal is what? To find out this r, which is what? Only magnitude part. So I will take the magnitude of this. So it is going to be 1 ka square and 3 ka square, so 9 10. Okay, this is the magnitude. But I also need what? AR cap. AR cap is what? The direction of the electric field intensity, which is what? Perpendicular to the line charge, but running parallel to this line joining the 2 points. Okay, this perpendicular line. So unit vector का formula क्या है? There is vector r divided by its magnitude. So it is going to be ax cap minus 3 az cap divided by root of 10. This is vector. Okay, so अभी आपने देखा फॉर्मूला तो छोटा सा है, लेकिन उसमें r और air cap निकालने में पूरा टाइम गया अपना. Okay, so let me just revise the things. This is going to be a constant. It's 10 pi nanocoulomb per meter. Okay, epsilon 8.85 into 10 raised to minus 12 हो जाएगा. R and AR cap, these two things are required. R is what? A perpendicular line joining the 2 points. Which 2 points? So the destination point and any point on this line charge, but finally this line, this whatever line you will draw to connect your line charge and the destination point, that line must be what? Perpendicular. So R is what? Perpendicular distance from the line charge distribution to the destination. Okay, so how to find out this? So first you should know the vector joining these 2 points, any point on the line charge and this destination point. So what you can do, destination coordinates minus the source coordinate, that you remove that coordinate along which your line charge is running parallel to. So in our case, this line charge is what? Running parallel to the y-axis, so that y coordinate can be simply discarded and at both the locations, and whatever is left, work on that. So now the destination coordinate is what? 1 minus 1, and the source coordinate and the coordinate at this line charge will be 0 and 2. So 1 minus 0 and minus 1 minus 2. Okay, so this will give you what? Vector length. Now this vector length will be what? Perpendicular length to this line charge. So find out its magnitude. From that you find out unit vector, and now if everything is ready, you can use the formula to find out electric field intensity. So electric field intensity, because of a line charge, is going to be rho L. It is 10 pi as far as I remember, divided by 2 pi. Epsilon is 8.85 into 10 raised to minus 12 into 1 by r, so it is root 10, and the vector, it is ax cap minus 3 times of az cap divided by root of 10. So this part is nothing but your AR cap. This is 1 by r, and this is the substitution. Okay, so if you'll simplify, you will get your answer. Now the total electric field will be what? Electric field because of surface charge density at x-axis plus electric field due to the surface charge density at y-axis plus electric field because of the line charge. So here xz is there, and in the earlier case it was x and z and y and z, something like that. Okay, sorry, z was not there, x and y and x and y, and here x and z is there. So whatever whatever components are coming together, like x, these are coming together. So if you have to add all this, okay, if y is getting repeated, add it, whichever coordinate is what vector is involved multiple times, you have to add those coordinates, and you will get the final answer. Now, if any query is there, you can ask. Okay, if you don't have any doubt, then we can have a break of 5 minutes, and we'll proceed for the other topics.
सर सॉरी टू इंटरप्ट सर
हाँ
सर हम लोग को ये मॉड्यूल आज मिल सकता है
हाँ, मैं अपलोड कर देता हूँ इसको.
सर
ओके.
थैंक यू सर
Recording stopped.
सर
Recording in progress.
Okay, we can move to the another topic from the electric field intensity only. Now the next is what? Gauss law. So Gauss law is one of the important law for us. Okay, because it further what you say means further information you can retrieve about the electric field. Okay, and that is nothing but the flux. Okay, invisible lines of force means one point charge, it influences the other point charge without any physical contact. So something has to be there. Okay, so that is nothing but your invisible lines of force. And these are called as what? Flux. So it can be electric in nature or it can be magnetic in nature, right? So simply the Gauss law, it says that the amount of flux is always equals to charge enclosed. Okay, so we'll focus on this. What is this charge enclosed, and why the Gauss says that, okay, it's charge enclosed is always equals to flux. Okay, so for that, there is one experiment, and that experiment is what? Like I think it was performed when the area was under development. Okay, the electric particle and its impact. So it's a spherical shell. Okay, so I will not draw this what you say, the aperture in this. Wait, I got it. मुझे नहीं मालूम वो 12 to 2 का उनका चक्कर. नहीं 10 मिनट का ही काम है वो, मैं ले लूंगा छोटी, इसमें लेक्चर के बाद ही ले लूंगा, चलेगा. ओके, हाँ. Okay, you will be having a short orientation after the lecture. After the means in the lecture only itself. Okay. So I was saying that this is a spherical shell. Okay, and a small aperture is here, available here, hole. Okay, now the arrangement is that there is no charge. Either it's a metallic sphere. Huh? Just remember that there is no charge on the outer side of this sphere, and similarly on the inner side of the sphere. Okay, so internally it is grounded like this. Grounded means what? It is ensured that there is no charge inside. So you have to ground it so that if any charge is there because of friction or some other reason, if it is coming, then it will be grounded. It will be absorbed by the earth. And now this earthing is what? It is removed. Okay. Now the experiment was that a cork ball was used. It was charged first, okay, by rubbing it with some other material. So what happens that cork, it gets charged. So this cork is there. So it is charged like this. So plenty of charges are present there. Now that is what inserted inside this sphere, like this. Okay. Now already we have seen discussed the electric field intensity. So what is going to happen, since it's a charged particle, so it is going to influence the surrounding. Okay, so how does it influence? Actually, it radiates out imaginary lines of force, which we call as what? Flux, like this, in all direction, like this. It's like this. Okay, and what happens that since it is a metallic structure, then now it's a positive cork is positively charged and it radiates out flux. So what happens that it falls here. Now, when we talk about the metals, so the property of metal is what? That it contains free particles. Okay, free particles means what? The electrons which can move, which are free to move actually. Okay, means even if you apply a small energy from outer side, then the electrons, they are going to move, or randomly they are moving before any application of the external force. Randomly they can move. So that is the meaning of what one of the property of the metal, that free electrons are there. Now those electrons, because they are negatively charged, they will get influenced by this positive cork. So the electron, it will get appear on the inner surface of this sphere. Okay, like this. But remember that the situation was what? That this sphere, it was not containing any outer charge, means it was neutral. So if the negative particles are they are getting accumulated on the inner side, then exactly opposite particle will get accumulated on the upper side, like this. Okay, so total net charge on this sphere is going to be 0. Okay, because we haven't added any charge on this. Now, if suppose this inner charge is grounded with the help of this arrangement. Okay, so the moment it is grounded means what? There won't be any negative particle inside. Oof. Negative particle won't be there inside this sphere. Okay, so I will remove this negative particle. And after that, this cork is what? It is taken out. There is no cork inside. And this sphere, it is there still. Okay, like this. So, but what happens that since the inner charge, it is grounded, cork is taken out. So what happens that on the outer side, there are positively charged, they are still there. Now this charge is measured. Okay, so let us consider that the amount of charge on this cork is suppose positive Q, and the amount of charge which was measured on the surface of this outer surface of this sphere, that also is what? Q only. Okay, it means that the amount of charge on the cork and the amount of charge on the sphere, it is same. But what was the factor which is responsible for generating this amount of charge? So we consider that it's imaginary lines of force, that is nothing but the flux. So finally it was concluded that the amount of charge, since on both the bodies are same, so the factor which produced this charge on the outer surface of the body, there is nothing but the flux. The amount of flux radiated by the cork, it must be equals to the amount of charge. Then only that flux will produce same amount of charge on the outer surface of this sphere. That's why it is said that psi equals to q, but q is what? Enclosed. Enclosed means what? Whatever charge was enclosed inside this sphere. Okay, so you take any random body, closed surface, and if suppose there is 10 nanocoulomb charge is there, so that charge, if suppose it is radiating out the flux, okay, like this, then the amount of flux will be equals to what? That 10 nanocoulomb only. Okay, so but the condition is what? That surface is enclosing some charge, then only, yeah? Otherwise no. So this is what? Gauss law. Now I will move to the PPT so that we can get more insight into this flux wala concept. This we have seen. Flux density that we have to discuss, but that requires a good background of what? Flux density. Flux, sorry, not the flux density. Okay, so this is Gauss law. Gauss law is just a flux calculation. Okay, so this is the flux which is coming from a sheet of charge. I'm not interested in all this. This is the formula for the flux that we will see later on. Gauss law. Okay, this one. That the charge, it is enclosed in a closed sphere. So the amount of flux which will leave this sphere, that will be always equal to the charge enclosed. Quiz. Which surface, S1, S2, or S3 experiences most flux? Can you answer? Like this is S1 surface. It contains Q amount of charge. Okay. And then this is the another surface S2. This is the another surface S3. But if whichever surface you take, they are going to have Q inside them. So the question is what? Because the size of the surface area is what? Different. So the question is what? Which surface will have maximum number of flux coming out of it?
S3.
Yes?
S3.
S3, okay. Any other answer?
For S1.
S1, okay, fine. तीन ही तो ऑप्शन है वैसे, S3 हो गया, S1 हो गया, तो बच गया S2 अभी. No, all are going to have same flux because they are going to contain same amount of charge, ना? Whether you take S1, S1 के अंदर भी Q का ही charge है, Q amount का ही charge है. And forget about S1, दूसरा कोई surface S2 है. So that surface is also containing only Q amount of charge. So the flux which will be leaving out of that S2, that is going to be Q only.
But the density of the charge on the surface.
No, here we are talking about the flux only, not the density.
Okay.
Of course, the density depends on the area.
Area.
हाँ, so there it matters. So सबसे ज़्यादा dense तो S1 में ही रहेगा, and it can be seen here also in the diagram of it. S2 पे थोड़ा कम density हो जाएगा, S3 पे सबसे कम density रहेगा. But we are not talking about the density, we are talking about the flux. So flux का Gauss law use करने का. Amount of flux is what? The amount of charge enclosed in that closed surface. That's it. उसका आगे कुछ सोचने का ही नहीं. Here, how much flux is enclosed by surface S1, S2, S3 and S4? अभी कहाँ पर है ये? S1, okay. ठीक है. S4, okay. S3, okay. दिख रहा है. और क्या है? S2 भी, okay. Any guessing? S1 से कितना फ्लक्स आएगा? Any idea? S1 is this surface, हाँ, ये dark वाला, इतना ही है वो. So how much flux will leave this S1 surface? You have to stick to the definition only. The amount of flux leaving the closed surface will be equals to amount of charge present inside. So if I consider that this is the charge plus Q is present inside it. So of course the flux leaving this S1 will be Q, this only. Same is true for S2 and minus Q जो भी रहेगा. And if this is S3, ये surface है. So, and if the amount of charge, Archana ma'am, are you there? Because S3 मुझे समझ में नहीं आ रहा है. It is this surface or it is this surface. ये तो होना नहीं चाहिए because this represents the charge which is available here. Minus Q is the charge available here. So S3 is this another dark surface. So there is no charge inside this. Okay, so flux enclosed by this will be what? 0 only. Same is true for S4. The amount of charge enclosed by this, the amount of flux enclosed by this S4 will be what? Equals to the amount of charge. So charge कितना है यहाँ पर? Q है, यहाँ पे minus Q है. Total charge कितना हो जाएगा? 0. दोनों if you are adding both the charges, so it will become what? Plus Q and minus Q. So addition will be what? 0. So net flux enclosed by S4 will be 0. Okay. Fine. Find flux through sphere. Okay. So there is a charge which is outside this sphere, right? And this is the charge which is what? Radiating out the flux. So we are considering only that part of the flux which is what? Moving towards the sphere. Otherwise, remember that this charge is going to radiate out the flux in all possible direction. Okay? But we are interested only in what? Analysis of this closed surface. So what is the net amount of charge? Total flux through the spherical surface. Positive, negative, 0. Is going to be 0. Reason is what? If you'll consider this portion of the sphere, so flux is what? Entering into this, and the other portion, the flux is leaving. So net flux is what? 0 actually. Or you apply Gauss law, the amount of flux leaving or entering into this closed surface is what? Equals to the amount of charge inside it. So there is no charge inside it. So the net flow of the flux through this sphere is going to be 0. Or the flux passing through the sphere will be 0. Any query? If there is no query, then we'll move to the flux density topic. Okay, electric flux density. So we have got the idea about what? The flux density. Now, what I will do, share presentation. Okay. So flux density. So for that, I will use this some diagram, and after that we will move to the PPT for that. Now let us. We have got the idea that the flux.
Sir, I can't see the screen properly.
Properly means what?
Meaning it's just coming, sir has started screen share.
Okay, no, I got the message that screen sharing is paused. Okay, जैसा पहले time आया था problem. So I will share the main screen only. And that will be better. उससे हम लोग switch कर पाएंगे.
Okay.
Now is it visible?
Yes, sir.
Okay. So flux equals to what? Charge enclosed, right? Now, what I will do, I will use this relation to define what flux density. Okay. So it's D. Symbol for flux density is D. Okay. So it is flux density. Okay. Now flux density is, see the unit for the flux is same to what that charge only. So charge has got the unit of coulomb. So flux ka unit will be coulomb only. Okay. C. Now let us consider there is a closed surface like this. Okay. And it contains amount of charge. And because of which, what is happening there, the flux is coming out of this surface. And for the sake of simplicity, what we are going to do that we will consider that this is a spherical shell. Okay. It has got some radius R, right? So the area will be what? Area कितना हो जाएगा sphere का?
4 pi r square.
4 pi r square. 4 pi. I have taken radius of the sphere as what? R. So it is going to be r square, 4 pi r square. Okay. It's meter square. Now there are certain flux, amount of flux, which are leaving this area. So I have to calculate now what is the flux density. So simply it is what? The flux present on the surface. Okay. Divide by the surface area. A. So it becomes what? Psi divided by 4 pi, sorry, it's r square. Okay, so it becomes what? Coulomb per meter square. Now I will use this Gauss law. Since flux it is equals to what? Charge enclosed. So this spherical surface, it is enclosing some amount of charge. And due to that only this flux is coming out. So I will write it as what? Psi equals to Q enclosed, or simply I can write Q divided by 4 pi r square coulomb per meter square. Okay. So this becomes what? A flux density formula. Right. Now, if I bring the another formula which is known to you, that is electric field intensity because of certain charge Q at distance r. So it becomes what? 4 pi epsilon naught r square, right? So if you'll compare these two relation, this and this, so simply you can say that this is nothing but d by epsilon naught, or you can say that flux density, it is always equals to electric field intensity into, medium constant into what? Electric field intensity. So if you are expressing D in vector form, then the electric field should also be in vector form, or electric field is in vector form, then the flux density that also should be in vector form. Here is this. So the relation between what? The flux density and electric field intensity. Right. And now, if I consider this relation, then the formula for finding psi, it is equals to what? A into what? D. And in vector form, it is going to be, we'll just change the sequence, dot A, because psi is scalar quantity. So dot product of two vectors can give you a scalar quantity, or D dot ds, so vector area, differential area, if I integrate, then it is this. So these are the multiple relations which you have got from a single law, Gauss law. Okay, so what I will do now, I will stop this topic, EME, and I will share one PPT which is related to your higher studies. It is just for the sake of awareness. Every semester we conduct this awareness program so that the students, they will be aware about how to go for the higher studies. Okay. So you can have a break of 5 minutes because wait,
Recording
we
stopped.
can have a break of 5 minutes. Or because if I conduct it separately now, so 1 hour वो run करना पड़ेगा, which is, I don't think 1 hour का जरूरत है उसके लिए. That's why it's better that let it get over in this session only. अलग से आपको आना ना पड़े उसके लिए. Okay. So wait, I will download the PPT and then we can have a discussion on that. Is the screen visible?
Yes, sir.
Okay. So, see, I am one of the coordinators on behalf of HOC cell, that is higher studies, online certification, and online courses and certification. Okay. So HOC cell, it is there in C wing. Wait,
Recording in
it is there in
progress.
C wing 104. And our in charge HOC is Dr. Anil Vasoya. He's from computer department. Okay. So from every department, there are two coordinators. So from ENTC, I am one of the coordinators, and along with me, Sonali Singh ma'am is there. So we two are there. Our role is what? To coordinate with the students, to guide them for their higher studies with the help of the HOC cell, and to maintain the records also. Means how many students after completing their BE course, they're moving for higher studies, then which course. Okay. And other than that, now when I say higher studies, so either the students, they are preferring, majority of the students, they prefer to go for masters and outside India, and very few are there, hardly one or two students, those who are preferring to do their masters from the India, and that to IIT. Okay. So those who are going for outside master's course, they have to go through various exams like GRE is there, TOEFL is there. Okay. Then if people are interested in MBA, then GMAT, all those things are there. Okay. So what you have to do, because you're in second year, so by the end of your second year, you have to get ready. Means you must have a very clear picture whether you want to go for the masters or you are interested in simply the placement. Okay, whatever may be the situation, but you have to be ready for with that clear picture, that either placement or for higher studies, because you'll be asked to give your consent, and based on that you will be trained. Like if you are going for the placement, then in the third year itself your training will be started, and if you are going for higher studies, then we frequently organize some meetings with the resource persons from the outer universities like US University or Germany, Australia, like that. So we invite them, then they talk about what courses are there in their university, what facility you will get. Then whatever, they are here to solve your queries. Okay, and other than that, we also have our counselor, not from the college, but outside the college. So we invite one counselor who is having good idea about what the courses which are available, then how to go for the applications and the entire procedure, which course will be better for you as per your result. Okay. And if the result is not good, then what to do? All those queries are solved by that counselor, which we invite. Okay, so that arrangement is done by the college itself. Okay, so either you go outside or you remain in India. But of course, for India, there are different exams. CAT वगैरह हो जाएगा, MBA में गए तो, और technical में गए तो GATE. Okay, so here I will be putting more emphasis on GATE here. उसका reason है GATE का. Like you are knowing what for this GATE exam is actually. Okay, it is one thing is very clear that you can go for your higher study with the help of this GATE exam, like ME MTech हो जाओगे, or if your BE this result is very good and you are appearing in GATE and GATE का भी score अच्छा आता है, तो directly you can go for the PhD also. But वो exceptional cases होते हैं, वैसे students मिलते हैं, but बहुत rare होते हैं वैसे तो. But that also I have seen. Okay, and it is this exam is conducted by one of the IITs. Okay. GATE exam में like I have used this old PPT, but of course देयर इज फिक्स प्रोसीजर लाइक आपको पहला गेट का फॉर्म वगैरह का लास्ट डेट वगैरह सब डिक्लेयर हो जाएगा, देन यू हैव टू रजिस्टर इट फॉर द गेट। ओके, फिर गेट का आपका बीच में नोटिफिकेशंस वगैरह आते रहेगा, जो भी उससे रिलेटेड इंफॉर्मेशन रहेगा। देन गेट का एग्जाम आएगा, गेट का रिजल्ट डिक्लेयर होगा। ओके, ये सब 4 to 5 स्टेप्स होते हैं। ओके, बट रजिस्ट्रेशन इज मस्ट फॉर द गेट। उसके लिए कुछ फीस रहेगा, यू हैव टू पे। ऑनलाइन सब हो जाता है, नो नीड टू गो। और पहले तो हम लोग आईआईटी वगैरह भागते थे, बट अभी ऐसा कुछ है नहीं। बट गेट पे व्हाई आई एम मींस फोकसिंग ऑन द गेट एक्चुअली। सो गेट के लिए कैसा है, इट्स नॉट only that gate will help you to get into what your higher studies, but it also helps for the jobs. Okay, गवर्नमेंट सेक्टर में, पब्लिक सेक्टर यूनिट्स, उसमें एक जितने भी अभी गवर्नमेंट सेक्टर्स है मेजोरिटी में गेट इज मैंडेटरी। मीन्स इफ यू आर हैविंग गेट, then sometimes what happen that based on your gate score only you are recruited, or gate is just like entry pass. If you are having valid gate score, then you will be allowed to apply for the post whichever is declared, and after that you will be going through some interview procedure or a written test, but you will be allowed to do those things only if you are having valid gate score. I don't know why I'm calling square gate score. Okay, so agar valid gate score hai so it's fine, otherwise doors are closed for you. So majority of the government sector में अभी वैसा हो गया है कि gate is mandatory, चाहिए ही चाहिए. Okay, so that's why gate is important. Means if you want to go for government sector, so gate पे अगर focus करोगे तो ज़्यादा अच्छा रहेगा. And second year is the right time actually, because your majority of the subjects are from second and third year. Okay, what is the syllabus for that we'll see at the end. But second and third year ये दो साल है जिसमें you can prepare for your gate exams. उसके बाद अगर सोचो कि मैं अभी फाइनल में हो, लोग करते हैं नो डाउट, लेकिन फिर कैसा है कि यू हैव टू गिव एक्स्ट्रा टाइम फॉर दैट. अभी करोगे तो कैसा है कि यू आर हैविंग सब्जेक्ट, तो आपको ऐसा बर्डन जैसा नहीं लगेगा. नहीं तो बहुत से लोग कैसा है कि बी में कर रहे हैं तो बी भी मैनेज कर रहे हैं, फिर गेट का प्रिपरेशन भी मैनेज कर रहे हैं, तो वो थोड़ा एक मुश्किल हो जाता है. और उसके बाद क्या है, फाइनल में हो तो एक ही अटेम्प्ट मिलेगा आपको. अगर यहाँ से थर्ड ईयर से कर लिया तो थर्ड ईयर एंड फाइनल ईयर, दिस 2 years आर देयर फॉर यू. सो दोनों टाइम आप अटेम्प्ट कर सकते हो, और 2 साल के लिए इसका स्कोर, ये रिजल्ट जो है वो वैलिड रहता है. दिस ऑलरेडी वी हैव डिस्कस्ड. हाँ, ये रजिस्ट्रेशन, फिलिंग द फॉर्म, अपलोडिंग फोटोग्राफ्स, एप्लीकेशन पेमेंट, फी पेमेंट होता है. ओके, ये सब तो प्रोसेस है.
So your slide is squeeze.
Yes, sir. Sir, it's the first slide.
Still it is first slide.
Yes, sir.
कमाल है, यहाँ पे तो कुछ ऐसा इशू दिखा नहीं रखे. I will reshare it. अभी दिख रहा है?
Yes, sir.
ओके. गेट का कट ऑफ भी होता है. एंड इट डिपेंड्स ऑन द कैटेगरीज. उस कैटेगरी के हिसाब से हर एक का, जनरल का, ओबीसी का, एससी एसटी का अलग अलग क्राइटेरिया होता है. दिस आई हैव टेकन फॉर ENTC ओनली, नॉट फॉर द अदर ब्रांचेस, बिकॉज देयर आर टोटल 27 पेपर्स होता है अलग अलग एरियाज में. कट ऑफ के लिए क्राइटेरिया, नंबर ऑफ कैंडिडेट्स, देन डिफिकल्टी लेवल ऑफ द गेट पेपर. जैसा इस टाइम का शायद लोग बोल रहे थे बहुत इजी आ गया था, तो अभी उसमें कट ऑफ बहुत ऊपर जाएगा. फिर रैंक एंड मार्क्स. ओके, रैंक अलग होता है, मार्क्स अलग होता है. अगर इफ यू वांट टू गेट प्लेस्ड इनटू IITs, और NITs. So your rank should be what within 1000 के अंदर रहा तो अच्छी बात है, अदरवाइज मुश्किल हो जाता है. और मार्क्स जो रहेगा इट विल बी आउट ऑफ 100. हाँ, एंड देयर इज समथिंग कॉल्ड एज अ स्कोर. Score is out of 1000. Actual exam will be what for 100 marks. उस 100 को scale up करके वो score card बनाते हैं, which is for 1000 marks. And based on that, the ranking is decided. So अलग अलग चीजें हैं सब. But
Sir,
अगर
what is the cutoff for PSU?
PSUs का तो वो लोग डिक्लेयर करते हैं उस टाइम पे ही, जब भी वो लोग कोई भी पोस्ट वगैरह अनाउंस करेंगे ना, तो कट ऑफ का मोस्टली अभी तक देखा गया है ना कि दे आस्क फॉर द वैलिड स्कोर, दैट्स इट. तो उस टाइम जो IIT ने डिक्लेयर किया है कि भाई अभी जनरल के लिए इतना है, एटलीस्ट इतना स्कोर होना चाहिए, सो दिस इज वैलिड स्कोर, दिस और अबव दिस. तो अगर इफ यू आर फॉलोइंग इन द कैटेगरी ऑफ वैलिड स्कोर, क्योंकि कैसा है, पहले ऐसा होता था ना कि अगर आपका गेट्स का स्कोर आ गया है तो आपको कुछ एग्जाम वगैरह देने का जरूरत नहीं पड़ता था, बट अभी क्या कंपटीशन बहुत ज्यादा हो गया, तो व्हाट दे आर डूइंग दैट you should have a valid score, and whatever exams we are asking you to appear it and come. But if you don't have valid score, then please do not apply. ऐसा हो गया है.
Okay, sir.
सर अभी आपने वो कट ऑफ बताया था 26 पॉइंट समथिंग जनरल कैटेगरी, वो आउट ऑफ 100 में आउट ऑफ 1000 में?
हाँ, वो 100 में रहता है, 1000 में तो फिर तो मुश्किल हो जाएगा. नहीं, वो 100 का है.
ओके सर.
हाँ, और लास्ट टू लास्ट ईयर है ना आपका. लास्ट ईयर तो आपने थर्ड ईयर में एक स्टूडेंट आया था, मतलब वो फाइनल ईयर में रहेगा, लेकिन उसके पहले एक ने 67 निकाला था, अभी IIT बॉम्बे में है, प्रांशु. अर्चना मैम नोज हिम वेरी वेल बिकॉज आई थिंक अर्चना मैम का मेंटी था वो. प्रांशु अच्छा स्टूडेंट था. मैंने उनको फाइनल ईयर में 8th सेमेस्टर में पढ़ाया उसके पहले, सो देयर वाज नो कम्युनिकेशन बिटवीन मी एंड दैट क्लास. 67 स्कोर मेरे ख्याल से हाईएस्ट रहा होगा अपने TCT में अभी तक के स्कोर में. IIT बॉम्बे मिलना मतलब अच्छी बात है. ओके, सो ठीक है. मुझे मेनली आई एम इंटरेस्टेड इन व्हाट, ये कट ऑफ तो है हर साल अलग अलग, ऐसा सॉरी चेंज होते रहता है. और हाँ, ब्रांच वाइज भी देखो अलग अलग है. मैकेनिकल का 34 दिख रहा है. PSUs वो पहले भी हम लोग डिस्कशन कर चुके हैं इसके ऊपर. बट अभी से फोकस रहोगे ना, मैंने मतलब अभी कैसा है कि इतने सालों से हम लोग देख रहे हैं ना, स्टूडेंट नॉर्मली फाइनल ईयर में आने के बाद ही फोकस होता है, वो अच्छा नहीं है एक्चुअली. अगर आप 4 साल में ही सब कुछ खत्म कर लेते हो तो अच्छा है ना, उसके बाद वापस से टाइम, बहुत से लोग मतलब कुछ ब्रेक लेके फिर तैयारी करते हैं, उसमें टाइम वेस्ट होता है फालतू में. अभी से ही करना ज्यादा अच्छा रहता है. सब्जेक्ट्स मुझे ओके, ये हाँ, ये एक है DRDO, बेल, बार्क, BPCL, HPCL, NTPC, ONGC, कोल इंडिया. कोल में तो अपने शायद हमारे यहाँ पे एक फैकल्टी थे, बहुत मेरे ख्याल से 5-6 साल पहले की बात है, वो यहाँ पे रह के ही गेट दिया. वो उनका कोल इंडिया में हो गया, वो चले गए बाद में. मीन्स उन्होंने शायद मास्टर्स किया हुआ था, लेकिन वॉज ट्राइंग फॉर गवर्नमेंट सेक्टर, सो ही अपीयर्ड फॉर द गेट, आ गया वैलिड स्कोर और ही लेफ्ट.
सर बेल में जाने के चांसेस कितने हैं?
वो कैसा है देखो, चांसेस का बात होता है ना कि उसमें आ जाता है कि एप्लीकेशंस कितने आ जाते हैं और पोस्ट कितना है, उसके ऊपर रहता है. और इतना भी याद रखो ना, जैसे कि अगर सपोज बोले 1 लाख एप्लीकेशन आ गया है, तो इतना याद रखना ना कि वो 1 लाख में 1 लाख स्टूडेंट सीरियस नहीं रहते हैं. बहुत से लोग हैं ना, उसमें से 70% लोग हैं जस्ट ट्राई मारने के लिए जाते हैं. कुछ लोग ठीक ठाक प्रिपरेशन करके आते हैं, और बहुत कम क्राउड रहता है जो सीरियसली प्रिपेयर करके आया रहता है वो सब चीजों के लिए.
Sir, actually, I have studied in the one article that under 300 rank for the ENTC, they are going for the PSU.
कट हो गया आपका. हेलो.
Yes, sir.
आपका वॉइस कट हो गया था.
सर
300
मतलब मैं ये बोल रहा था सर, जो PSU है ना सर, मतलब मिनी रत्ना, महारत्ना,
हाँ,
उसके लिए अंडर सर 300 रैंक होता है ना सर ENTC के लिए.
हाँ
तो फिर सर हो जाता है और उसके बाद इंटरव्यू राउंड होता है।
ओके ओके फाइन। सब्जेक्ट के लिए मैं बोला था वो सब्जेक्ट जानना जरूरी है आपका। इंजीनियरिंग मैथमेटिक्स फर्स्ट ईयर से शुरू हो जाता है, तो सेकेंड थर्ड ईयर जब तक भी है मैथ्स सेकेंड ईयर तक रहता है, मैथ्स 4 तक। देन इलेक्ट्रिकल नेटवर्क जो आप लोग को लास्ट सेम में हो गया। मेजर ये जितने भी यहाँ पर लिस्टेड है ना सब्जेक्ट्स, उसमें नेटवर्क, सिग्नल सिस्टम, डिजिटल इलेक्ट्रॉनिक्स, ये मेजर क्वेश्चंस इस पे रहते हैं। उसके बाद आता है इलेक्ट्रॉनिक डिवाइसेस का। देन कंट्रोल सिस्टम, इतना भी अगर कर लिया ना, मतलब लीव दिस कम्युनिकेशन एंड इलेक्ट्रोमैग्नेट, बिकॉज इलेक्ट्रोमैग्नेट्स अभी आपको एक दिख रहा है, लेकिन इलेक्ट्रोमैग्नेट्स में अभी जो हम लोग लर्न कर रहे हैं वो आएगा। देन नेक्स्ट सेमेस्टर का एंटेना आ जाएगा, फिर उसके नेक्स्ट सेमेस्टर का आपको ये सॉरी नेक्स्ट टू नेक्स्ट सेमेस्टर का आपको माइक्रोवेव आ जाएगा। तो इलेक्ट्रोमैग्नेट्स में एक्चुअली 4 से 5 जिसने अच्छे से कर लिया है उसके लिए प्लस पॉइंट आ जाता है वो। तो कंट्रोल सिस्टम एक जरूरी है, नेटवर्क, सिग्नल सिस्टम्स, डिजिटल इलेक्ट्रॉनिक्स, ये अगर 5 सब्जेक्ट भी कर लिया आपने, तो आप एक गवर्नमेंट सेक्टर में ट्राई करने के लिए एलिजिबल हो जाते हो। और हाँ, ये रिसोर्सेज जहाँ से मैंने सब कंटेंट लिया था बहुत पहले वो है। सो अगर आपका प्लानिंग अभी, तो मैं नहीं सोचता हूँ कि आप लोग ने कुछ सोचा रहेगा ऐसा। सोचा है तो अच्छी बात है कि ये हायर स्टडीज के लिए जाना है कि प्लेसमेंट के लिए जाना है, बट थिंक ऑन दिस लाइन ऑल्सो।
सर ईएनटीसी वालों को टेक प्लेसमेंट में बैठने देते हैं?
Recording stopped.